So let me show some examples of rewriting integration bounds. So first let's consider R. Let R be the region enclosed by the graph of y equals x squared, y equal to 4, and then y equals 0, and x equals 0. So that's this little region to the left. So if we have a function, if we want to integrate a function f(x,y) over this region R, well, first, if we integrate with horizontal slices, meaning with respect to x first, so then our bounds are going to be, so this will now be an integral of f(x,y) dx dy, the y variable is going between 0 and 4, and then x at a given point is, so if y equals x squared, this is equivalent to x equals root y. So our bound here will be from 0 to root y. If instead we integrated with vertical slices, so with respect to y first, then we would get, can I write this? Then our integral would be, so if y is going up to 4 and x is root y, then that means that x will be going up to 2, and then like root, or we've already said the bottom value is x equal to 0. So x, so this will be integrating f(x,y) with respect to dy first, and then with respect to dx. So x is going to go from 0 to 2, and then y is going from, well, it's going up to 4 and starting at x squared, because in this graph we're only interested in the stuff above the curve y equals x squared, not below. So that's why we're starting at x squared. So a little bit in the converse direction, if we're given an integral in one order of integration, so let's say this goes from 0 to 1 and from 1 minus x to 1 minus x squared, let's see how to rewrite this integral in the opposite order of integration. Okay, so first let's sketch that region. So if we've got x on the outside, then x is going from 0 to 1. So this is our bounds for x. And then 1 minus x is this inverted line crossing the x or the y-axis at 1, and 1 minus x squared is this inverted parabola. So our region is this little slice, and in this order of integration, we are traversing this from x along the x direction, so with vertical slices. So to rewrite this in terms of y, well, y equals 1 minus x implies x equals 1 minus y, and y equals 1 minus x squared implies x equals root 1 minus y. And it is plus, like we don't have the negative root here because we're in a range where like x is positive or non-negative. And then similarly, both of these go between y. So 1 minus 0 is 0, and 1 minus 1 is 0. Or sorry, 1 minus 0 is 1, and the same 1 minus 1 squared is 0. So we see that the range is, for y, is also between 0 and 1. Okay, so this will be integral. So if we do dx dy, now that's traversing this along the y-axis. So y goes from 0 to 1, and then we said 1 minus y will be the lower x-coordinate, and root 1 minus y will be the upper x-coordinate.